My name is Kylie Bulger, and today I will be presenting on the topic of genetic, phenotypic, and environmental correlations, specifically those found in desirable traits of thoroughbred racehorses. Within this PowerPoint, I will be answering the following questions. What are genetic, phenotypic, and environmental correlations? What are the desired traits for thoroughbred racehorses? And lastly, how do these traits correlate genetically, phenotypically, and environmentally? In a broad and collective sense, genetic, phenotypic, and environmental correlations are a way of comparison. They can be used to determine how much specific traits affect one another in terms of performance. In his Understanding Animal Breeding book, Richard M. Borden defines genetic correlation as a measure of the strength, consistency, reliability of the relationship between breeding values for one trait and breeding values for another trait. He also defined it as a measure of pleiotropy. Borden also provided a definition of phenotypic correlation, a measure of the strength, consistency, reliability of the relationship between performance in one trait and performance in another trait. Lastly, he defined environmental correlation as a measure of the strength, consistency, reliability of the relationship between environmental effects on one trait and environmental effects on another trait. Some of the desirable traits for thoroughbred racehorses are speed, endurance, good conformation and bone structure, and high lung capacity. For obvious reasons, thoroughbred racehorses are desired to be fast. A fast horse wins races, and that is the goal. Owners and breeders also want thoroughbreds who possess endurance. Horses with endurance can maintain speed for a longer period of time, which makes them more competitive and successful. Next, conformation and bone structure is a very important trait in thoroughbred racehorses. Good conformation will allow the horse to move more effectively with less strain and less potential for injury. Horses with good bone structure, especially good legs, are preferable because they will be able to run faster with more ease and are less prone to injuries. When a horse has balanced and strong conformation but is still athletic and not overweight or bulky, they are ideal. In order to pass on good conformation traits, horses with poor conformation are typically not bred after the racing careers because their traits are not desirable. Lastly, traits for high lung capacity are desired in thoroughbred racehorses. Horses that have a higher lung capacity will be able to take in more air, breathe better, run faster and longer, and exhibit higher performance levels. Horses with low lung capacity will not be as successful. For the sake of this presentation, I will be comparing speed with good conformation and endurance with lung capacity. Genetic correlation between speed and conformation. These two traits appear to have a strong positive genetic correlation because if a horse has good conformation and good bone structure, it is found that they can run at higher speeds. The genes that influence conformation correlate with the horse's speed. Lastly, if a horse has a high breeding value for good conformation, chances are they will have a higher breeding value for speed because their physical structure influences how fast they are able to run. The genetic correlation between endurance and lung capacity is also a strong positive. If a horse has strong lungs, they will breathe better and therefore be able to run longer. A horse that has a high breeding value for good lungs will also have a high breeding value and ability to pass off good endurance to their offspring. There is a strong positive phenotypic correlation between speed and conformation. This is a pretty simple one to grasp. Horses with above average performance for conformation tend to have above average performance for speed. On the other hand, horses with poor conformation tend to have poorly performing speed. Not surprisingly, endurance and lung capacity also have a strong positive phenotypic correlation. Horses that have above average performance in lung capacity tend to have above average performance in endurance. A famous example of this is the renowned Secretariat, who was found to have tremendous lung capacity and blood and oxygen pumping ability. Secretariat is known as one of the greatest racehorses of all time due to his extreme speed and very impressive endurance. If a horse has poor lung capacity, they will typically have poor endurance and will not be able to run for as long successfully. The last type of correlation I will discuss is environmental. Speed and conformation have a strong positive environmental correlation because the same environmental factors that may affect one trait may affect the other in the same way. Some examples of environmental factors are the track conditions such as fast, wet, deep, dirt footing, turf footing, and the hardness of the surface. Horses who have a certain type of conformation may run faster on turf than dirt, or vice versa. The environment could cause a horse's conformation to deteriorate if it causes them to suffer an injury. This injury will then affect their speed because they will not be able to run as fast even if they recover from the injury. Endurance and lung capacity have a strong positive environmental correlation as well. The quality of the air the horse breathes in will directly affect their lung performance as well as endurance. If a horse is breathing in dusty or bad air, their lung capacity will not be as good and they will therefore not be able to run as long because their endurance level will fall. It can be concluded that a racehorse's conformation heavily affects its speed and that its lung capacity heavily affects its endurance. This knowledge can be used to breed horses with good conformation and high lung capacity in order to produce offspring with above average speed and endurance performance. Thank you for watching. These are my references.